Okay, so now that we managed to bring in our boxes here, let's press start and see what happens. Again, if it doesn't look like that for you, but maybe more like this, remember the defaults have changed. In the pop object, we will talk about this right now in this video, the friction by default in the past was set to 0. So if you want the same behavior as in the video, just set it to 0 and then you can see it looks pretty much like we just saw in the video. And as you can see, there's an awful lot of bouncing going on for some reason. Now what's happening here is that our particles have so-called physical properties and we can change them, and actually not only the particles have that, but also the collision objects and the ground. And you will find that, let's start with the particles in the pop object, of course, under the tab physical, and we will find this tab in other contexts later on over and over. And what you can find here, which is the most important part, is bounce and friction, and actually bounce forward. And what we will see is in the ground plane we have the same physical tab and then a static object as well here right in the beginning. And let's first start by dialing down the bounce, which is set to 1 for the points. And by the way, this is set to 1, which means it bounces by a certain amount. And if you would increase that to a higher number than 1, then it becomes unphysical, because then they would basically bounce higher than they would actually do physically. So that means you would add energy to the whole thing, so it becomes unphysical. So my point is, never go over 1, it will always look kind of weird. So let's dial this to 0, and when we do this, then you can see it looks much better and we don't have bounce anymore. Now keep in mind this is actually multiplied, so while we lowered the bounciness for our points, the bounciness of the ground plane in the static object is still there. So for example, if we set the bounce back for the points and set it for the 2 boxes in the static object to 0, then what we will see is that there's no bounce on the boxes, but there's still bounces on the ground. So depending on what you want, you have to adjust the settings, where you need them. In our case, we want to dial it down for everything, not just for the static object. So let's maybe leave that at 0.5 or something and lower the bounce for the points. Now you might have already seen this. Here this looks a bit weird, and actually the collision is not correct. This is something we will look at in the next video. So for now I will simply fix that. Just ignore what I'm doing. I go here and increase basically the resolution of something, of my collision object, and then it looks much better. For now, ignore this. We will talk about this in the next video. Very important video. Now, when we talk about the settings here, those properties, the first thing, of course, is bounce, which we don't want. But another important thing is friction, because as you can see, currently they behave, especially on the ground, you can see that, they basically behave as if there was no friction at all. They keep sliding around on the ground. Especially for something like sand or something, that doesn't feel very natural and is certainly not correct. So what you would think, you would increase the friction, and you're right, if you would do this, then the effect would be that they become slower and it looks much more correct. And there's absolutely nothing wrong with that, but keep in mind there's another important option, and that is the bounce forward. And this is a bit confusing for beginners. Basically what the bounce forward is kind of the inverse of the friction. So the higher the friction, the more friction there will be, and the lower the bounce forward, the less there will be rolling movement, so to say. So this controls basically how much an object can move. So they both are very, very similar, the bounce forward and the friction. And this is why I usually do not change the friction, but just lower the bounce forward, because that just means that the points, imagine them as if they would be rolling, can't roll that much. In my experience, this has the advantage of being easier to control, because you basically have just one slider that you care about. Play around with this. In the end, friction and bounce forward are kind of doing the same thing. They just control it in a different way. So friction is kind of actual friction, and bounce forward is, so to say, freedom of movement, if you will. There's not much more to say about this other than that we said we can change the settings for each object. So for example, if you wanted to have 2 different settings for each box, you might consider bringing in 2 static objects, so that you can then in the physical tab change the settings for one box and differently to another. One word though about the last thing, temperature we completely ignore for now because this is for much later, but one word about the dynamic friction. This can be interesting under very rare circumstances, and basically this describes the phenomena that friction is actually dependent on the speed of the object. An example, if you have a sleigh or something on a frozen lake, and it's very big and there's a lot of stuff on the sleigh, and you want to move that thing with your own muscle strength. When you try to push it out of the standing, then the sleigh will be really, really hard to move. But once it is moving, you will notice that it's barely any strength that you need to keep it moving. And this is kind of what dynamic friction describes. The friction goes down once an object is faster, and this is what you can control with it. And it actually kind of explains this to you. So basically, the lower you do this, the less friction will be there when the point is moving. In this example, I can't really show this, but here's the thing. Dynamic friction, I have personally never seen anyone using. This is very, very rare that you need that. So I would recommend just ignoring that. The most important ones are technically bounce and friction. But again, my tip is use bounce forward. It comes out the same and basically is a quicker way of getting the result you want. Now, one last thing, when we talk about friction, we do not talk about stickiness. So for example, if I have a case like that where I set my start velocity in my pop source towards this box and it collides, no matter how high I will put the friction, the points will not stick. So let's have a look. In the static object, I can increase the friction to 1, lower the bounce to 0 and the bounce forward to 0. And just to be safe, let's do the same in the pop object. Bounce forward maybe even to 0 and friction to 1. And now we should have something that should be super high friction. And as you can see, it still collides with the box. At the same time, if we would do this with our example here, then it would almost feel like it's sticking because the points are not moving at all. But they are simply not moving along the gravity. That doesn't mean they stick on the box. They would technically still fall off if the gravity would be into another direction. Now, as a quick tip, if you really wanted to have stickiness, I want to quickly show you how to do it. You can go into the pop solver under collision behavior and then turn on add hit attributes. Basically, that means the thing will handle collisions, and then it has a very quick way of doing what you want. You can switch the response to stick. Now, there's a lot more to talk about this, and we will talk about this later on, but this is as a quick, information how, if you really, really want to do this, this is how you can turn this function on. Keep in mind though, this stickiness will then stick to anything, not just to this box. But for now, we turn this off because this is not what we want. We wanted to talk about the physical properties, and you find those almost always in a tab called physical, where you can change the actual behavior of your collision objects. Now, just for you to know, later on when you're a bit more advanced, you don't even have to rely on a general properties, settings for all the points, but you can actually set your properties for each point separately via attributes. Now, the only disadvantage of this is, and we will look at this in a later video, that you can't just take any input as a source for the pop source. You would have to create the points yourself that are then used and emitted from. Again, we will look at how to do this in one of the next videos. But what you can then do, and currently I just turned the bounce to 0 and the bounce forward to 1. You can, for example, set an attribute called bounce differently for each point, and I do this via the attribute randomize node. And then you can see that each point actually has a different bounce amount based on, of course, the bounce attribute it gets, which will override the internal bounce. And here in the geometry spreadsheet, you can see that each point has a different bounce attribute. The same is true for the attribute called bounce forward in one word. And then if I give each point a random number between 0 and 1, I think, then you can see some of them are pretty, lazy, let's call it, and some move freely, and then you have way more variation in your setup. And then, of course, this is also true for the attribute friction. So if I do the same for the friction attribute, you will get a different friction for each point. Again, this only will work when you actually have points that you can set those attributes to. So in our current setup that we've looked at so far, we don't have that. Okay, just for the sake of it, because some people asked, this is meant as a bonus information for people who really feel like they understand all this already. In case you want to have that function, you could actually, instead of doing this from the outside, you can also do it from the inside. The first direct way of doing this is using the pop wrangle, because a pop wrangle is basically like a wrangle inside of pops. And here what you could do is you can just override the bounce attribute with, let's say, a random number based on the point number. Now, something we will talk about later, this should be ID, not point number as we know it. Usually we would type in ptnum, but it's actually ID. And then what you would get is a random bounce for each point during the simulation. And to prove that, I'd say multiply it by 3, and then you can see that some of them are really high, so this node is actually doing something. Sometimes you will also see, instead of a pop wrangle, a node called pop properties. Personally, I find this node useless because I can do everything I want with Vex. But if, just to explain why some people will use it, you can do the same here. So you can, for example, override the bounds for all points, which again, I found pretty pointless, but you could also use the Vexpression where you override that. And here you wouldn't use the at in the beginning, but just write bounds. And then what we just saw, random ID, and make sure with a semicolon you finish this. And then you would change the bounce factor for each point during the simulation, not before it. And again, to prove that this actually works, let's multiply the result by 3. And now some points should jump up quite a lot. And there you go, it works. For most people, this is not interesting, but since a lot of tutorials show you this, I just want to make sure that I at least mention it. You can use the pop wrangle, which I would prefer, or the pop properties to override a certain attribute of a point during the simulation. And about this ID thing, we will talk more about in a later video. And again, there's another problem that we will talk about in a second. There's still something wrong with my collision object. Now, this is something we will talk about now. So for now, I hope the whole physical properties thing was helpful. So thanks very much and see you later. Cheers.